Hello and welcome back to PolyToots. In this video we're going to be creating some foliage that we can control the scale of. It also has a basic wind system and subsurface scattering for when the light is behind it. I'd like to thank Pontus Karlsson for his amazing video on fluffy stylized trees. I learned a lot from that video and promise that this isn't a total rip-off. But if you are interested in billboarded foliage, I will leave a link in the description for his video. This shader is available for both Shader Graph and Amplify over on my Patreon, but since we covered Shader Graph in the last shader tutorial, this video will be done in Amplify and we'll be using URP for this. So let's clear out our scene and get started. The first thing we'll cover is the mesh that we'll be using. We do have to make our own, but it's super easy. You could probably make this within Unity by using something like ProBuilder or UModeler. The main thing that you need to keep in mind is the mesh must be all quads and the UVs must be mapped to each quad. This can be called face mapping if you're unfamiliar or familiar with it. Not to be confused with unwrapping faces, I guess. I'll be using Blender for this, and it's as easy as starting with a box, subdividing it once, extrude for the general shape you're after, and then smooth it out or move some verts around for the final shape. The grab tool in Blender's Sculpt Room helps a lot with this sort of thing. I'm also going to make sure this mesh has smooth faces because unlike Pontus Karlsson's video, we're not going with a billboard effect, so having smooth mesh normals will work in our favor. I also want to make sure that the pivot point is at the center of the object. This will be pretty important later. Next up, we need to sort out the UVs. Since each quad here will represent a piece of foliage, we need to map each quad. In Blender this is easy, but first we'll apply our subdivision modifier so that all of the geometry that we have here is kept. Then hop on over to the UV room, select all of your faces and go to UV, reset, done. Now we can export this mesh out as an FBX and get it into Unity. From here we can get started on the shader, and again we'll be using the Amplify editor for this, but if you're using Shader Graph on the Universal Render pipeline, then the setup is pretty much the same. So I'm going to make an Amplify shader, Universal, and choose PBR. You could go the route of using an unlit shader for this depending on how far away your foliage is, but having default self-shadowing really helps the visuals on this, plus you get smoothness and access to normal maps as well if you want it to be all super fancy. So let's start with the quad scattering, which technically isn't scattering, but quad scaling just isn't as catchy. To do this, we're going to tell the shader that we want to split and scale our geometry based on the UVs. This is why all of our quads are mapped independently. So we'll start with a UV coordinate node, and now we need to remap this because UV space goes from 0 to 1 on the X and Y, meaning 0 is the bottom left point, and it goes up to 1 on the Y and across to 1 on the X. Ideally, we want to scale them at the center. Think of it like each quad's pivot point. We need that pivot to be at the center of the face, not in the bottom left. So if we change our remap here and leave everything as default except the new minimum, you can see that as we go into the negative, we're repositioning that bottom left corner. And since the old values were 0 to 1, we need the new values to be -1 to 1, because now 0 would be in the middle. I'm pretty sure the preview for that in Amplify is a little offset, but the math checks out, so we can just move on. If we multiply this by a value, which we'll keep for later, so I'll name this fluffy scale, and make sure it's a property, and then hook this straight into the vertex offset, you can see that the quads are being split, but the scaling is a little wonky. Also, if you rotate around, you can see that the backside is not behaving at all. And if we look at it from the side, you can see that it's only scaling on 2 axes. So we need to inject that magical third axis and also make sure the quads are staying in their original object orientation. To do these two things, we just need one node in Amplify, and that's the transform direction, which we want to set from tangent to object, since tangent space is the coordinates for each face, and object space is the coordinates for the object. So it's like we're saying, hey, I like what's going on here, you know, the splitting and the scaling and all of that is great, I love it, it's perfect, but if we could just apply that same thing in object space, then that would also be perfect. And then this node here says yes to that, which is, you know, nice. We also want to normalize this, which just helps keep the scaling intact as we transition from one space to another, like, you know, tangent to object. In Amplify, this actually doesn't make a huge difference. I'm not sure what's going on behind the scenes with this node, but in Shader Graph, this setup definitely requires the normalize node. And we'd also have to turn the UVs into a vector 3 first, but yeah, for some reason we don't need that in Amplify, which is good, I guess, and weird. So now if we take a look at what's happening, we're getting a nice scale across each face. It's working in object space too, so the scaling is happening around the whole mesh. And since this is in object space, we can rotate our foliage around and everything stays in place. Very cool. We're done here for now. We will come back to this setup to plug the wind in, but we can safely move on to some backlighting. Let's just have a little tidy up first. I'm going to use a register node to hook our quad scattering setup into. Call it something that makes sense, and with everything selected, I'll press C to group these, move it out of the way, then create a get node and get the register we just made and hook that into the vertex offset. Done. I'm also going to enable our skybox in the scene, since the light direction is quite important for the effect we're about to make. So important, in fact, that the first node we'll make will be the world space light direction. We want to dot product this with a view direction. The reason we're using a dot product is we're dealing with two different direction vectors. I'm not an expert by any means, but in this context, what we're interested in is finding out the direction of two vectors, light and view direction. And we just need to know at what point they're positive or negative. For us, this would be if the light is in front or behind our viewing angle. I'll throw down a saturate here to stop the values from going beyond 0 and 1 and get this hooked into the emission via our old friends register and get, and you'll see what I mean. As you can see, when I change our viewing angle so the light is behind us but in front of the object, it is outputting a white value. And if we go behind the object, it's like nothing has changed at all. This is because we're saturating the values, so 0 is as low as it can go, and 0 emission is basically like no emission. And obviously we want the positive value to appear when we're at the opposite angle with the light behind us. So we'll need to tell the shader that the light direction needs flipping, and we do that with a negate node. You can see immediately that this is having the right result. It is a little strong though, and of course we can come back here and multiply our light direction by a property to control its strength, which, it would do as you expect. But we can push this a little further by giving priority to the light on the outside of the mesh only. We do all of this by multiplying another transform direction and then add that to the light direction instead. This time our transform direction is going to go from object to world, so we'll hook in a vertex position node. The reason we do this is we need to know the vertex position relative to the object origin. And for us, the object's origin, otherwise known as a pivot point, is its center of mass. So we can basically use our center of mass as a mask for our light. And we have to transform it to world space, otherwise if we rotated our mesh, then the light would rotate with it, which is, obviously not cool. One last thing to do here is to chuck in a bit of color, set it to a property and multiply it into the chain at the end. I suppose we should probably address the fact that there's no texture on this. Obviously the style and content of the texture you use will drastically change how your foliage looks, and the texture I'll be using is included in the download of course, but I do encourage you to create your own and experiment with the results. So let's start by dropping down a texture node. We'll also multiply this by a color because tinting your texture is always handy. I'll register this, and I'll also make another register node for our alpha. We're going to use cutout alpha for this, and if you're developing for mobile, then I recommend going with regular transparency, which might sound a bit backwards, but we don't have time to get into that. So I'll just go get our gets and plug those into the albedo and alpha respectively. By default, alpha is not enabled, and for us, we don't actually need to enable it here. Instead, what we'll do is create a float down here and plug it into the alpha clip threshold, which will let the shader know what we're trying to do. I set this to 0.5, which is usually the default clip value, but feel free to turn this into a property and adjust it on the material if you're feeling adventurous. I'm also going to add in a smoothness value here, turn it into a slider, and set the default to 0.3, just because I don't want super glossy leaves. Oh, and if you get this error about too many interpolators, that's because at the time of recording, Amplify will default the shader model to 2, and we've hit a bit of a limit on the amount of instructions that we can do, so I need to change the model over to at least 3, which we can do here. And honestly, this is not a problem. Even ancient phones by today's standards support shader model 3, so, then parazi, as they say in the land of Souvlaki. Let's check in our texture here, and as you can see, it's looking mostly fine. The fake light from the backside is of course just pure white, since we're using white as the emission. We could overlay the light with the texture before plugging it into the emission. We can even multiply it with the light color itself. So now even if we leave the SSS color as white, it will draw from the color of our texture and be influenced by the light color. Obviously, if you want to keep it simple, then just rip all that out and change the color manually. Sometimes the simplest is all you need. If you wanted a more colorful result for your texture, what I tend to do is the laziest thing possible, which is just to add a HDR range onto your initial tint color. Don't blast this too high though, as it will obviously be a bit crazy. It also contributes to the bloom if you're using it, so yeah, caution. One last thing to mention before we crack on with the wind is that you can of course change the tiling on the texture to get different results. It's not a game changer or anything, but if you're in a pinch and for some reason your boss has only given you 8 seconds to come up with a whole new bush, then happy days. Also, get a new boss. Okay, so wind. One common way to do simple wind on foliage is to alter vertex positions of the mesh based on a panning noise map. So as the noise pans, your verts go all wibbly wobbly, and that's exactly what we're going to do with some minor additions. The first thing we're going to do is get ourselves some world space UVs, and we make this with a world position node and append the X and Z, because those are the coordinates I want to project from, which in this case is the vertical axis, but it doesn't really matter which axis you choose. Since we're only outputting a vector 2, I'll change this append to a vector 2, and then we can multiply this by a property. This will be the tiling of our new UVs, and it's only going to exist as a property temporarily. Once I'm happy with the size of my noise, I will probably hide this from the inspector. Now we need something to inherit this that will ultimately control our verts. So we're going to use a small tiling noise texture. You can use a procedural noise generator if you want. Both Amplify and Shadergraph have these, but it's often a good rule to steer clear of these if you can replace the functionality with a tiny texture instead. We do need this to scroll as well, so let's also throw in a panner node and we'll plug our UVs into the panner and then the panner into the texture's UVs. For the panner's speed, I'm going to set the X and Y to 1. In this context, the 1 is just to enable scrolling in that direction. For the actual strength of the direction, we'll control that with a classic blend of time multiplied by a value. At this point, we've probably got something worth having a look at, so I'm going to create a register here, give it a name, and then come over to the master output, and just for preview's sake, I'll get that wind scroll noise, dehook our albedo, and replace the emission with this. From here, we can play with the noise scale and the scrolling speed. This is what will eventually affect the movement of our verts, where white will be the wind and black will not. It's important to have areas of rest for this stuff. You don't want everything jiggling all the time, that's just messy. So what I'm looking for here is quite a big scale, so there will be obvious areas of wind and no wind. Then I can use the scrolling speed to determine how fast this all needs to be. I'm happy to leave the scale at 0.1, but as you can see, the speed value is entering the annoying range. Nobody wants to faff about with 0.0 numbers, and we'll sort that out later when I'm more certain of the acceptable speed ranges. Back to the shader for now then. Let's put the previous albedo and emission back in place, and I'll grab this get node for the wind and come up to our quad scatter setup and add our wind into the equation via a multiply of a vertex normal node. This is just us telling the shader that we want the black and white areas of our texture to have an effect on the vertex normals. Also, before I forget, I'll come to the noise scale, set it to 0.1 and turn it into a constant. I'm happy to never adjust this again on the material, but obviously you can leave it if you want. If we give this a quick save, you'll see we've got something going on already. This is nice, but it's not great. We have an issue where too much is happening and it's difficult to see the areas of rest. One easy fix for this is to come back to the wind setup here and chuck in a power node at the end and give it a value of maybe like 2 or 1.5. Now you can clearly see there's areas that are not being blown about, and this is much better in my opinion. We can still do better though. What if instead of this robotic back and forth of highs and lows, we introduce a secondary layer of noise to cause a bit of jiggle? To do this, we're going to need some differently scaled noise scrolling at a different speed. So first of all, I'm going to come to our world space UVs here, and I want to multiply the output by 2, which is basically just giving us twice the tiling amount. And I'll hook that into a new panner node, again setting the X and Y to 1. And then I'll make another texture node and set this to a reference and use the original wind texture as the reference and then hook up the panner UVs into this. Now we just need some different time, and I'll reuse the time we already have, but multiply this by a new property called wind jitter. If we go and see what this looks like, it's basically causing the verts to jitter about a bit whenever the original wind noise is coming into effect. And with our new property, we can control the strength of this jitter, and much like with our property for the scrolling speed, we need to be careful of what values we use here. So I'm going to play about with both to work out what my mins and maxes should be. For example, I don't think I want my wind scroll to ever exceed 0.1, and weirdly enough, I'll probably go with the same for the jitter. So back in the shader, I'm going to turn these properties into sliders going from 0 to 1, and then remap these values so that 0 is still equal to 0, but 1 will equal 0.1. So now when we come back to the material in 3 months' time, we don't have to worry about remembering what values work well. I think that's that. I'm just going to tidy up the property order on the material here and get ready to call it a day. So there we are, one more overly lengthy tutorial to add to the collection. I hope this has been of some use. Remember that all source files, including the shader graph version, are available over on my Patreon, and of course I cannot thank my patrons enough. I'm going to have to think of some other solution to the end credits of my videos at this rate, because there's just so many of you now. So, obviously, thank you very much. And yeah, this is the end of the video with a awkward sign off. So see you in the next one. Bye bye.